All right, and in this video, I'm going to show you how you verify that this scatter plot is really a line, okay? And the way you verify if this scatter plot is really a line, a linear pattern, you're going to follow these 7 steps. I'm using the same data set and scatter plot that I used in my previous videos, just that I'm going to now verify that this scatter plot is really showing you a linear pattern. So step number 1, in this step, you're always using this hypothesis, null hypothesis and alternative hypothesis. It's always these two options, null and alternative hypothesis, HO and H1. Sometimes they call it HA. And basically HO is saying that this scatter plot is not a linear pattern, no significant correlation. And H1 or HA is stating the opposite of HO, that there is a linear pattern. So step 1, you're always using this. Step 2, you're going to find out who is your alpha. Okay, and who's your alpha here? Well, alpha is your significance level. Now, when usually they specify this in the word problem, but when they don't, when it's not specified, we're going to assume that our alpha is always 0.05, okay? So most of the time they will specify this in the word problem, but in this case, nothing was specified, so we always assume that it's 0.05 because that's a common percentage we use in statistics, okay? Next step, step number 3, I'm going to find the degrees of freedom. And how do I find the degrees of freedom? I'm going to take the sample size and subtract 2. Now, what is my sample size? How many points you have in the scatter plot? Now, sometimes when you have a lot of points, it would not be wise to count the points. Instead, look at the table and find how many rows or pair of numbers you have. And you can see here I have 5, okay? So it will be, n will be 5 minus 2. So my degrees of freedom is 3. Okay, step number 4, you just need to do this bell-shaped curve. That's what I'm going to draw here. And this bell-shaped curve is always two-tailed. And if you remember from previous week, who decide the tail, H1 or HA? And because I have the not equal, that's why it's two-tailed. Okay, so that's step number 4. That's it. Step number 5, you're going to find the test statistic. Okay, what is the test statistic? A number that I'm going to use to label my marks here. Okay, and you can see that that number, we're going to find it using this formula, T equal, okay, R. So I need my R. Now, where did I get the R? Remember when we did this in a previous video, we found R in Excel. Look, my R is 0.99. Subtract, I'm sorry, not subtract, over the square root of 1 minus R square. Now, R square, if you did it in Excel, you already have R square, 0.98, over n minus 2, and n minus 2 is the degrees of freedom, so in this case will be 3. And then just use Desmos calculator. That's what I'm going to do right now. I'm going to call my calculator and I'm going to type all of this in Desmos. So here's my fraction, bar 0.99 on the top. On the bottom I have square root. Inside the square root I have a fraction, 1 minus 0.98 divided by 3. And you can see I got 12 point in a long decimal there. Usually the test statistic is always 2 decimal places, so it will be 12.12 here. Okay, and that's my test statistic. And what exactly that means, that this number is the label of this mark here on the right. Why? Because in the middle we have 0 here. Okay, and then who's going to be the label of this mark? The same number but opposite sign. Okay, and there it is. And I did step number 5. I'm sorry, I also forgot that in step 5 you have to find the p-value. And how do you find the p-value? Well, the p-value, you're going to have to use the t calculator that we used in previous week. Okay, and you can see that I'm going to have to fill in these two boxes. So the degrees of freedom was 3, you remember from the steps. Okay, df 3, and my t value is 12.12. And then click calculate. And when you click calculate, you're going to have 3 answers, see? And which one you're going to use out of these 3 answers? The one that says two-tail, because that's my picture. And you can see my probability is this decimal, but usually we round to 3 decimal places. So it's going to be 0.001. Okay, and I found my p-value. So I did step 5. Step 6 is when I make the decision. How do I make the decision? Well, I hope you remember this chart from previous week. And I'm going to compare the p-value against my alpha. And my p-value came out to be 0.001. And my alpha was 0.05. My significance level. And from left to right, 0.001 is smaller than 0.05. And what will be my decision according to the chart? When the p-value is smaller than alpha, we're going to say reject HO. That's our decision. Okay, that will be. And I did step 6. And then step 7, okay, it says to make sense of your decision and the original claim. Basically, here's what you need to understand. If you rejected HO, and that's what happened here, it means that the scatter plot, okay, is really a line. In statistic, we say there is enough evidence to conclude that there is a significant linear correlation. In layman terms, this scatter plot is really a line. I hope this helps.